Bernoulli's principle. Bernoulli's principle. A flowing liquid, a flowing fluid possesses three types of energies. A fluid in flow possesses three types of energies. One is potential energy, other one is kinetic energy. Potential energy, kinetic energy, and along with these two, there is another type of energy possessed by a fluid, that is pressure energy. A fluid in flow, a fluid in motion possesses potential energy, kinetic energy, and pressure energy. Pressure energy. Bernoulli says that the sum of these three energies, potential energy plus kinetic energy plus pressure energy, is constant at every point and at any instant. For a flowing fluid, or for a fluid in motion, the sum of the three energies is constant. That is, potential energy plus kinetic energy plus pressure energy is a constant. This is Bernoulli's principle. Let us derive a relation for Bernoulli's principle. Let us consider a fluid in motion, and in a fluid in motion, consider a tube of flow as shown in the figure. Consider a tube of flow as shown in the figure. Let us suppose the fluid is flowing from left to right. From left to right. The area of cross section of the left end is A1, and the fluid is entering this cross section with a speed V1 and it is at a pressure P1. This cross section is at a height H1 from the ground. So, the fluid is entering the cross section A1 with a velocity V1 and the fluid is at a pressure P1 and this cross section is at a height H1 from the ground. The fluid is leaving the cross section. The fluid is leaving the cross section A2 with a velocity V2 and the fluid at a pressure P2. The fluid is leaving the cross section A2 with a velocity V2 and at pressure P2. The end of this tube of flow or the cross section A2 is at a height H2 from the ground. It is at a height H2 from the ground. Suppose the density of the fluid is rho and let us consider a small interval of time dt. In a small interval of time dt, the volume of the fluid entering the cross section A1 is A1 V1 dt. A1 V1 dt is the volume of the fluid that enters the cross section A1. And the mass of the fluid entering is volume multiplied by density. So, A1 V1 dt rho is the mass of the fluid entering the cross section A1. And the volume of the fluid leaving at A2, the volume of the fluid leaving at the cross section A2 is A2 V2 dt. A2 V2 dt is the volume of the fluid leaving in a small interval of time dt. And the mass of the fluid leaving is A2 V2 dt rho. A2 V2 dt rho. From the continuity equation, the mass entering is equal to mass leaving. So, A1 V1 dt rho is equal to A1 V1 dt rho is equal to A2 V2 dt rho. A2 V2 dt rho. Let us suppose that A1 V1 dt rho is equal to A2 V2 dt rho is equal to dm, a small mass dm. When a fluid is in motion, the loss of potential energy and the loss of pressure energy will be equal to the gain in kinetic energy. From conservation law, the total energy should remain constant. So whenever there is loss in one form, it should appear in another form. Here in this case, there is loss in potential energy and pressure energy, and this becomes equal to the gain in kinetic energy. The loss in potential energy is initial potential energy P1 V1 dt, P1 V1 dt, and the pressure energy at the second end is P2 A2 dt. P1 A1 V1 dt is the pressure at cross section A1. P1 A1 V1 dt is the pressure energy at cross section A1. P1 A1 V1 dt is the pressure energy at cross section A1. P2 A2 V2 dt. P2 A2 V2 dt is the pressure energy at cross section A2. Hence, the loss in pressure energy is P1 A1 V1 dt minus P1 A1 V1 dt minus P2 A2 V2 dt. P2 A2 V2 dt. The loss in potential energy. The loss in potential energy is dm into H1 minus H2 into G. dm H1G minus dm H2G, that is equal to dm into H1 minus H2G. This is loss in potential energy. The gain in kinetic energy is half mv2 square minus half dm v1 square. Half dm v2 square minus half dm v1 square. From Bernoulli's principle, the total energy remains constant, or the loss in pressure energy plus the loss in potential energy, the loss in pressure energy plus the loss in potential energy is equal to the gain in kinetic energy. So mathematically it becomes P1 A1 V1 dt, P1 A1 V1 dt minus P2 A2 V2 dt, P2 A2 V2 dt plus dm H1G minus dm H2G, dm H1G minus dm H2G, or dm into H1 minus H2G, dm into H1 minus H2G is equal to half dm into V2 square minus V1 square, half into V2 square minus V1 square into dm, half dm into V2 square minus V1 square. This is the mathematical relation we obtain from Bernoulli's principle. We have already assumed that dm is equal to A1 V1 dt rho, A1 V1 dt rho is equal to A2 V2 dt rho, A2 V2 dt rho. Let us divide each term with dm. P1 A1 V1 dt divided by dm, P1 A1 V1 dt divided by dm minus P2 A2 V2 dt divided by dm, P2 A2 V2 dt divided by dm plus dm into H1 minus H2 into G, dm into H1 minus H2 into G divided by dm is equal to half into dm into V2 square minus V1 square by dm, half into dm into V2 square minus V1 square divided by dm, or P1 A1 V1 dt divided by P1 A1 V1 dt divided by A1 V1 dt rho, A1 V1 dt rho minus P2 A2 V2 dt, P2 A2 V2 dt divided by A2 V2 dt rho, A2 V2 dt rho plus dm into H2 minus H21 into G divided by dm, dm into H1 minus H2 into G divided by dm is equal to half into dm into V2 square minus V1 square, V2 square minus V1 square divided by dm. divided by dm. By cancelling a1 v1 dt in the first term, by cancelling a1 v1 dt in the first term, a2 v2 dt in the second term, a2 v2 dt in the second term, and dm in the last two terms, dm in the last two terms, we get p1 by rho, p1 by rho minus p2 by rho minus p2 by rho plus h1 minus h2 into g, h1 minus h2 into g is equal to half into v2 square minus v1 square, half into v2 square minus v1 square. p1 by rho minus p2 by rho plus h2 minus h21 into g is equal to half into v2 square minus v1 square. This can be rearranged into p1 by rho plus h1g plus half v1 square plus half v1 square is equal to p2 by rho plus h2g plus half v2 square plus half v2 square. From this we understand that p by rho plus half v square plus gh, p by rho plus half v square plus gh is a constant. p by rho plus half v square plus gh is equal to a constant. Different forms of Bernoulli's principle. Mathematical relation obtained for Bernoulli's principle is p by rho plus half v square plus gh is constant. This is the relation for unit mass. That is, the energy per unit mass is a constant. The energy per unit mass is a constant. That is the sum of pressure energy, potential energy and kinetic energy. The sum of pressure energy per unit mass, kinetic energy per unit mass and potential energy per unit mass is a constant. P by rho is pressure energy per unit mass, half v square is kinetic energy per unit mass and gh is potential energy per unit mass. So sum of the energies per unit mass energies is a constant. Similarly, by multiplying with rho, we get the relation p plus half rho v square, p plus half rho v square plus rho gh is constant. P plus half rho v square plus rho gh is a constant. This is the relation for unit volume. P is pressure energy per unit volume. Half rho v square is kinetic energy per unit volume. Rho gh is potential energy per unit volume. So the sum of the three energies is constant. This is the relation for unit volume. Another relation for Bernoulli's principle is p by rho g plus 1 by 2 rho into v square plus h is equal to constant. That is, by dividing the first equation with g, we get the relation. Or by dividing the second equation with rho g, we get this equation. P by rho g plus 1 by 2g into v square plus h is equal to constant. This relation is obtained by dividing the first equation with g or the second equation with rho g. In this equation, p by rho g is called pressure head. 1 by 2g into v square is called velocity head. and H is called gravitational head. Gravitational head. Sum of these three is constant. This is another form of Bernoulli's principle. So the different mathematical forms of Bernoulli's principle are: one is P by rho plus half V square plus GH is constant. This is sum of the energies unit mass per unit mass is constant. Another one is P plus half rho V square plus rho GH is constant. This is the relation for unit volume. Similarly, P by rho G plus 1 by 2G into V square plus H is constant. These three are the three forms of Bernoulli's principle, mathematical forms of Bernoulli's principle. In the case of the tube of flow, we have considered the two ends are at different heights. Instead of considering different heights, if we consider a tube laid horizontally, that is, when a fluid is flowing horizontally, then the relation will be reduced to the form P plus half rho V square is constant. P plus half rho V square is constant.